So,
time to get this.
ratios, you guys remember what they are? What's the ratio of, let's say, guys to girls in this class?
17 to 4.
4, 5, 6, 7, 8.
63, 1,
1, 2, 3,
63,
4, 5.
2 to
5
1.
over 8.
2 to 1. 2 to 1.
Okay. Yeah, if you counted me,
Oh, there's
7 to 3.
it would be 6 to 3. Okay, you're thinking of a fraction. 5 out of 8
There's 6 of us.
is a fraction. Okay, there's 6 boys and 3 girls. So the ratio of boys to girls, you guys remember how to write
I was
ratios?
counting Jada twice.
You can use the colon, you can use the word
Because
two,
one of my-
or you can say, yeah, fraction 6 over 3. 6, but 6 to 3, 6 to 3, 6 to 3. Can you reduce ratios?
Yes.
Yes. Just like you reduce a fraction, divide those both by 3 and you get 2 to 1. So if the ratio of guys to girls is 2 to 1, does that mean that there's 2 guys and 1 girl?
No.
No. It's more like there's 2 guys for every 1 girl, or 1 girl for every 2 guys. But yeah, that's what a ratio is. It's different than a normal fraction because a normal fraction tells you how many there are compared to the total. It's like a ratio of guys to the entire class or girls to the entire class. Ratio just compares two different numbers. Okay, so the reason that we're using that is because today we're talking about similarity. And similar things. You guys remember the chapter we did congruent stuff? Usually triangles, but not always triangles. Congruent is when all the sides are the same, all the angles are the same, all the corresponding parts are the same. But similar means what?
They're close, but not the exact same.
Okay, they're not the same size, but they are the same shape. Okay, similar things. So let's be a little more specific. What do you think we know about the angles in similar figures, similar things? What do you think we know about angle A and angle Y, for example? They are the same. So not all the angles are the same as all the other angles. It's the corresponding angles, the matching angles are the same. So like angle A is congruent to angle Y, angle B congruent to angle, this is supposed to be an X, angle C congruent to angle Z. Okay, what about the sides? Are they the same?
No.
No. The angles are identical, but the sides are not. But how are they related? Let's say this one is like 12 and 10 and 9. Oh, that doesn't look right. Let's put this over here. I'll move that around so it looks a little bit better. All right, and this one was 6 and 5 and okay. So the sides aren't the same, but there is a relationship. Do you guys know what the relationship is? Okay, the ratios of the sides are the same. So 12 to 6, that ratio equals 10 to 5. These both reduce to 2 to 1. 12 over 6 equals 10 over 5 equals 9 over, what would this one have to be? 4.5. So basically in this example, all these sides are twice as long as this side. So all of these, 9 over 4.5, they all reduce to 2 to 1. That ratio that they reduce to is called a similarity. This book calls it similarity ratio. Some books call it scale factor. I've seen that before. It just means the ratio of any corresponding sides in similar shapes. Okay. Dang, I forgot something I was going to say. So anyway, all those ratios are the same. And you guys remember back in the congruent triangles chapter, how we wrote a congruent statement, like triangle ABC is congruent to triangle, whatever, DEF. So in this case, there's something similar with similar triangles. So the similar symbol is a squiggly. So triangle ABC is similar to triangle what? Y. Right. ABC, you have to match it. YXC. So it's not alphabetical order. You have to make the matching. A matches Y, B matches X, C matches Z. You got to do it in matching order. Okay. So just looking at this, I know that angle A is congruent to angle Y, angle B is congruent to angle X, and angle C is congruent to angle Z. But I also know that side AB should match, they're not the same, but the ratio of those two sides should equal the ratio of BC over XC, should equal the ratio of AC over YZ. You guys see where I got that? Okay, so AB over YX, the ratio of those two sides should match the ratio of these two sides, should match the ratio of these two sides. You can tell just by looking at the picture or by looking at this, what the matching sides are. I know what I was going to say. When you have a bunch of equal ratios or just two equal ratios, it's called a proportion. So if you say something is proportional, that just means the ratios are equal. So let's say a 50-pound, second grader, I don't know. How much would a first
That
grader?
is a
50
big
pound
old
goat.
second grader.
Is it?
No.
Well, that's probably average.
Really?
Actually, this is small.
That's actually small
Really?
for us.
That's,
Yeah.
I don't feel like
No,
there's
it's
no
not-
place
it's
that's
not.
that big.
When I was like in fifth grade, I weighed like 80 pounds.
Really? I didn't think
Well,
my little buddy
in
was
second
that
grade, anyway, it
Well,
doesn't
not
matter.
fifth grade. I don't know.
So let's say a
big. That's the big.
50-pound second grader, whatever, eats like 8 ounces of food for lunch. Okay, if we want it to be proportional for the size of the kid, then how much should a 150-pound?
I can literally lateral raise that for reps.
Well, a 150-pound kid should eat how much?
For
24 ounces.
24
50
ounces, which is actually, that's a ton of food. So this, maybe, I don't know, this wouldn't work exactly, but maybe 8 ounces is too much for a second grader.
I mean, Easton
That's
eats.
a big old second grader.
Easton eats that much, and he's like 150. That's
Easton?
also
24 ounces is like a pound and a half.
Is he bulky? I don't know what.
Yeah, he's
but
on the ultimate bulk that.
No,
he's
he just loves to eat.
I like seeing him eating up his food.
No,
and
he
it's
wants
like
to
a
get-
bowl
he
that
wants to
like
get
this
bigger.
big.
Yeah, he eats like 3 Chick-fil-A sandwiches.
But if he
with
doesn't eat
fries.
that much, like he's gonna.
Okay,
shrink.
anyways, the point is that these are equal ratios, right? This would be a proportion. The amount that you eat is proportional to your size. That can be. Okay. Anyways,
Gotta put this bad boy up.
Don't
Yeah.
forget to put your.
I was too distracted to put it up because I was focused on math.
He's locked in.
somehow I don't believe that. Okay. How could I, if I don't know one of these sides, how could I find it? That's kind of a question for today.
Like since 10 is twice as big as 5.
Okay, yeah, but what if it's messy? Like,
It doesn't have to
let's
be
say
messy.
this is, sometimes it is. So let's say this is like a 3 or something. I don't know. Here, let's just do that. 5 and there. How could I find X there?
I don't know.
X squared.
Okay, the ratios have to be equal, right? So what would the ratios be on this one? Okay, 12
9.
over
5.
5.
5.
Actually, you can do it more than one way. You could do 12 over 9 should equal 5 over x. Usually we go from triangle to triangle over polygon to polygon. So 12 over 5 would equal
9 over x.
9 over x. then how would we solve something like that?
You would divide.
Yeah.
Okay, so here's what you do. You divide 12 divided by 9, and then whatever that is, you know, I'm wrong. I did it earlier.
1.2.
Okay, anytime you have, there are a couple ways to do it, but anytime you have two equal fractions, two equal ratios, whatever, the easiest way is to cross multiply. Okay,
Butterfly.
if the answer is not obvious. So 12 times x equals 5 times 9. So when the answer is not obvious, like this one's twice as big as the other one, you can use cross multiply. So yeah, 12x equals 45. So to solve for x, we would divide by 12. It's kind of a messy one. Let's see, that'd be 36. If we divided those by 3, it would just be like 15/4.
Yeah.
It's like 3 3/4 or something. Anyways. Alright, let's get going here. Number 1.
Let's get it.
Find the scale factor for a 36-inch tall scale model of the 288 feet tall United States Capitol building. So the scale factor just means the ratio between the parts. So a 36-inch tall scale compared to a 288 feet tall building. Okay. Now, there's a problem. The ratio really isn't 36 to 288 because what's the problem?
There. Yeah.
They're not the same measurement type, so that's misleading. So how could I fix it? This is inches, this is feet.
You could do 3 feet, it's 280.
Right. So we either need to change inches into feet. How do we change inches into feet? Huh?
12 inches.
Yeah, because it takes 12 inches to make 1 foot, you'd have to divide by 12. Or we could change feet into inches. Each foot is 12 inches, so 288 feet is times 12. But it's probably easiest because 12 goes into 36. If we divide that by 12, that would be 3 feet to 288 feet. Does that reduce?
196.
Yeah, it does. 1 to 96. Which basically means the Capitol State Building is 96 times taller than the little model of the building is. All the dimensions are 96 times. Okay, if you can reduce any of these ratios, you do need to, like on number 2. Those all reduce. Okay, number 3, solve the proportion. 2/3 equals y over 18. Now, you could cross multiply, but there is an easier way. Do you guys know
I
what?
don't know.
Okay, what is it?
Okay, so you divide 18 divided by 3.
Okay, 3 times what is 18?
6.
6. So the top one is going to be the same ratios.
Booyah!
So y is 12.
Do it.
Okay, number 5, that trick's not going to work too hot because it's a mess. So it's 5 over a equals 2/3. Right. 2a equals 5 times 13. 3, I'm sorry. So 2a equals 15. So a is 7.5 or 15 over 2. Right. This one might throw us.
Busters.
Any ideas?
6 plus 4 times 2 equals 4 times 3.
Would it just be c equals square root of 2?
Yeah.
Because the 4 would cancel out.
Listen here, busters.
It'd be 6.
Or can you just do-
equals 6 equals 12.
Where are you getting 6c from?
Well, 4 times 2. Like
You just
cross.
use c times, or c plus 8 equals 4 plus, or 4 times 3.
Close.
Is it c plus 1 equals square root of 2?
No. You can't just divide this. you cannot, you can't just divide this by 4 because it's everything divided by 4. You'd have to divide both of them. So you can't just
Oh,
divide
so
one
C
thing.
over
That's
4?
why you subtract it.
C over 4 plus 1 equals this. That would be true, but I'm not going to do it that way.
Wait, why plus 1?
8 plus C times.
2C plus 8?
It's not 2 times 4, it's 2 times, yeah,
I say it from Kyle, but now you're not.
yeah, it's 2 times C plus 4, right? Not just 2 times 4, not just 2 times C, it's 2 times that, equals 3 times 4. So yeah, it's 2C plus 8 equals 12.
Definitely not natty.
So C equals
Yes. 2C equals 4, therefore, thus. Okay, number 9, write a similarity statement for each of a pair of similar figures. What do you think they mean by similarity statement?
Like triangle.
Yeah.
ABC's congruent to
No,
triangle.
not congruent, it's similar this
Yeah,
time.
this is what
Unlike the past thing. Okay, so if I did start with triangle ABC on the left triangle, that would match triangle what?
DFE.
Right. ABC, the order on the second one would be DFE. Because A matches D, B matches F, C matches E. Okay, then after that, they say they want the then write an extended proportion relating the lengths of the sides. So what's the equal ratios for the sides going to be?
CD's congruent to FE.
Okay, no, the sides aren't congruent. It's the ratio of the sides that are congruent. So AB, for example, over side, what AB matches FD. Whatever that ratio is should equal what other ratio? BC over FE,
Or would it be EF?
same thing. Would equal AC over what?
ED.
Yeah, ED or DE. Okay, you can get that from the picture. I'm assuming that's where you got it from, but you can also get it from right here. AB over DF equals BC over FE equals AC over DE. Okay? Number 11. Number 11, find the similarity ratio of the red polygon to the similar black polygon. So the order matters because they said red to black. So that means the red one needs to come first. So how would we find the similarity ratio from red to black? Just find the ratio of two corresponding sides. What's two matching sides on number 11? 15 and 10, but we got to go red to black.
10.
So 10 to 15. Does that reduce?
Yeah, I would take those.
2 to 3. Okay, what if I had used 20? What does 20 go with? 30. What does that reduce to?
2/3.
And what if I'd used 14 and 21? Okay, so do you have to do that 3 times? No. The point is, all those ratios are the same. But the answer is just 2 to 3.
That's how I share it 2/3.
Yeah, the reason I keep saying 2 to 3 is because 2 to 3 is different than 2 out of 3. So it's not really a fraction. It's not 2 compared to the total of 3. It's 2 compared to just a different number. That's 3. Ratios are not the exact same things as fractions. Fractions are kind of like a special type of ratio that always compares something to the total. What? Okay, number 13. We got to find the missing XYZ stuff. give me like 20 minutes to draw this.
I don't judge people
I'm
for
kind of
how
a-
long it takes to draw.
Yeah, I was about to make a Whitley comment. I'm gonna make up a disease name and name it after Whitley.
Next time Scott's gonna be like, did you take your meds? I'll take
I've got Whitley.
Whitley-itis.
Whitleyitis. Okay, so we gotta find, I guess we'll start with X, we'll do it alphabetically. How could I find X? What does X match? So X over 24, did I copy these right? And I've not been copying very well today. Yeah, okay. X over 24 equals what?
18 over y.
Wait, 20.
Okay, X to 24 is the same as,
18.
well, you could say Y to 18, but
9 to
what's the problem with that?
There's
Two variables can't be solved, so we need two numbers that we know. So we, okay, 9, 27. Now, do 9 and 27 reduce?
Yeah.
Yeah. Do we have to reduce it? No, it'll come out right either way, but if the numbers are smaller, it makes it a little easier, right? So 9 and 27. 1 to 3 would be the similarity ratio. So this, anyways, so 3x equals 1 times 24. So x is 8.
Yeah.
All right, who wants to try y? Setup for y. All right, Timothy.
Y over 18 equals 9 over 27.
Or, yeah.
So then you would cross multiply and get 3y and 18 divided by 3. 6.
Okay, somebody else z?
12 or z over 12.
Could we do 12 over z? What do you think?
Could just have to do 27.
Yeah. It works that way. 12 over z equals, go ahead, Roman.
Wait, I'm lost.
Okay, you wanted to do z over 12 again?
What's up, everyone? It's your boy.
Okay, z over 12 equals what?
Wait, 9 over 1, or 9 over 3. Oh,
9 over
3,
20.
1 over 3.
9 over 27 or 1 over 3? So 3z equals 12. So z is
4.
okay, now, if the ratio is like 3 to 1, that just means all these sides are 3/3 of this. You could like divide all these by 3. The problem is if you don't know how to do the cross multiply trick, like when you get to number 15, you're gonna be lost because it's not, 15 is not as easy as 1 to 3. But we could have really just divided all those by 3. But 15 is kind of a mess, so I'm not going to draw that, by the way. Okay, somebody besides Timothy and Roman, how could we set up for A on 15?
4 over 6.
Okay, 4 over 6 if you're going from the left to the right. Equals what?
Oh wait, 3 over.
Okay, 3 over A. Yeah, that would work. So 4 is the bottom on the left one, 6 is the bottom on the right one. 3 matches A on the left. 3 on the left is like A on the right. Let's put it that way. So yeah, that would work. We could reduce 4 and 6, but let's go. Okay, that's 2 to 3, right? That's the similarity ratio. So 2A equals 9. So A is 9/2 or 4.5 is fine.
So it's not going to be decimal or.
Yeah.
Get to play up.
All right. Paxton, how about B? How would that set up?
On the B,
B.
you got 3, 5. Right?
No, I don't know which. Okay, what does B match on the left?
3 and 5.
No, just the 5, yeah, just the 5. So B goes with 5, just like what?
5 goes with B.
Okay, what else? Another ratio.
4 goes with 6.
Okay, that's true, but if we do B is to 5 as what is to what?
6. So
6 is to 4. So if we go B on top, then 6 needs to go on top. We could have done 5 on top. 5 over B equals 4 or 6. That's kind of what we did last time. A was on the bottom. All right. And we could reduce that too, but 4B equals 5 times 6, 30. 30 divided by 4 is 15 over 2, or 7.5. Okay, number 17. A recipe for caramel calls for brown sugar and whipping cream in a 4-to-1 ratio. Okay, so we got a ratio, 4-to-1. The 4 goes with what? Brown sugar, and the 1 goes with whipping cream. And then it says, if you use 8 ounces of whipping cream, how much brown sugar should we use? So where do I put the 8 ounces? On the bottom, because I put whipping cream down there. So the ratio, and then how much brown sugar should I use? Okay. So, right. Basically the 4-to-1 ratio just tells me there's 4 times as much brown sugar as there is whipping cream, but yeah. If we cross multiply, 1B equals 4 times 8. So that would be 32 ounces of brown sugar. I don't know why they threw that in the geometry lesson, but whatever. It's okay. It's all math.
Are you a fan of fishing, Mr. Jordan?
Okay, number 19. You just kind of gotta find a pattern on these and finish the equation. So up in the directions it tells us that x over 5 equals y over 7. If that is true, 19 says 5y should equal what? 7x. They just cross multiplied. Just gotta kind of find the pattern here. So on 21 it then says x over y should equal what?
5 over 7.
Yeah, x over y should equal 5 over 7. Yeah, when you set up these ratios, we kind of did it the same way every time, pretty much, but there's actually more than one way you could set it up. As long as you're following the pattern, it still works. Okay, on 22 it says, given triangle blah 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 is similar to triangle RST, list all known pairs of congruent angles. So it's triangles, so there should be 3 pairs of congruent angles. And write an extended proportion relating the lengths of the sides. So this is like number 9, where we said like AB over XY is equal to BC over, YZ, whatever. It's just like the answer from number 9. So the first part is like angle L is going to be congruent to angle R. Angle P congruent to angle S, that kind of thing. 3 pairs of angles, and then the 3 side ratios that must be equal. So LP over RS is equal to PQ over ST, that kind of thing. Got it? Just like 9. Okay, 23. We're supposed to figure out if these polygons are similar. If so, write a similarity statement and the similarity ratio. If not, state why not. Okay, so on 23, to be similar, you have to have all the same angles and the sides have to be in proportion. The ratios have to be equal. So are all the angles the same on 23?
Yeah.
Yeah, they're all 90. Are all rectangles similar?
Well, yes.
Are those 2 rectangles similar?
Yes.
No.
Well, their size different, but
Well, the shape is different. Okay. Not only do the angles have to be the same, the sides have to be in proportion. Are all squares similar?
yes.
Yeah, because no matter what numbers you pick for a square, like say these are like 7.5s, and these are like 2s or something, the ratio is the same. But not so with rectangles, not all rectangles. So we need to check and see if those ratios are the same. So does 14 over 21 equal 21 over 31.5?
Yeah.
So how can we check this? You could divide both of those and see if they're the same, or you could cross multiply and see if those are equal. Okay, yeah. If you reduce them both, he said he divided those by 1.5. I don't know what made you think of that, but yeah, that does reduce to 14 and 21. Yeah, both of these, like if you divided them, are like 0.6 repeating. Put it that way, 2/3. So they are the same. Or if you cross multiply, they're equal. So all the angles are the same. The sides are proportional. So yes, they are similar rectangles. So we need to say a similarity statement. For example, rectangle FGHE. There is no rectangle symbol, by the way. There's only triangle symbol. Is similar to what? FGHE is similar to. Okay, if I start with FG. Yeah, it actually works both ways because, if you flip the rectangle sideways, it's the same. But let's just do KLMJ so it looks the same. KLMJ. And then we have to state the similarity ratio, which is just the ratio of any 2 corresponding sides, like 14 to 21. What does the 14 to 21 reduce to, though? Right, if you divide them by 7, that would be 2 to 3. So that is the similarity ratio.
So could you get the other one too, though, for the ratio?
Yeah, I don't know if your calculator would reduce this, but because that's a decimal right there, it might screw it up. But yeah, this is also a 2 to 3 ratio. Okay, 25. Are all the sides in proportion on 25? Does 8 over 5 equal 8 over 5 equal 8 over 5 equal 8 over 5? Yes. So the sides are proportional. Are the angles the same? What do the angles in a quadrilateral have to add up to? 360. So, oh, no.
Sounds like Mr. Totino.
That's the guy I get to hang out with after school.
Golfing?
Do you hear about Mr. Smith?
Pretty nice out today.
Yeah.
Which part?
That he's retired.
Yeah.
He's cried.
Are you sad?
If you retire, I'll literally leave. It's not worth
Hey, you gotta be
it.
the one teacher that survives all our years of high school. Because Mr. Odell was last year. Miss Conrad's leaving next year.
Wait, what?
Yeah.
She said she'll probably,
Mr.
No,
Odell,
she's
she'll be here
leaving
next year.
yeah, she said she'll probably leave when Sam graduates.
Mr. Leach left.
Oh, yeah, cause her husband does,
He works in OKC.
his job's out
So
of.
you gotta stick around, alright?
Yeah, she almost left
You
last year, actually.
You got me.
I know.
You got me.
Sure. Alright.
And Miss
So-
Porter's leaving next year too.
No, you just.
You're just making stuff up.
Who's leaving next year? Who'd you say?
He's lying.
Okay, so these two have to both be 112 because it's a parallelogram, but how do I find these two angles?
Oh, 112 plus 112 and then 360 minus that.
Yeah, you finally
I
said
did
that.
it.
360 minus 224, and then because there's two of them, that would have to be divided by 2, right? So, let's see, what does that come out to? 126 divided by 2,
I'm gonna beat you.
60.
My money's on Mr. Jordan.
It is, oh crap.
Oh, it's 136 divided by 2, so it's 78,
You're too slow.
or 68, 68.
68.
Okay, so anyway, does this match the other, their rhombus is what they are, but 68s, does that match the other one?
We got to be not 7.
That one has a 72 right there.
So no.
So no.
Not
So we're gonna put, corresponding angles are not congruent, so they're not similar. Corresponding,
Sunday, Monday, Tuesday, Wednesday,
Tuesday.
Thursday, Friday, Saturday.
You know how the British say schedule?
Schedule.
Schedule. They don't say vacation, they say holiday.
Don't they look like beans and toast?
Only
Vegemite.
Jolly or a day would matter.
That's like the weirdest thing.
Okay, on 27, we need to see if these sides are proportional. So if I use 4.2 on the left triangle, what side should that match on the right triangle?
3.4.
3.4. Do you know how we know that? Because 4.2 is the smallest on the left triangle, then it should match the smallest on the right triangle. Okay, if they are going to be similar, that has to happen. So 4.2 should go with 3.4, and that needs to equal, if I do 5.0 on the left triangle, what should that match on the right? No, 4.5, because that is the middle value. So that has to be equal, and also it has to equal 7.2 to 6. So how can we tell if those are equal or not? Okay, two ways. You could cross multiply, like twice, or you could just divide, like that divided by that, that divided by that, that divided by that. Do they all come out the same?
Ooh, that's a doozy.
That's a bit racist.
That's racist, actually.
Oh yeah, that's
Racist.
racist actually. I don't even remember what we said, but it's not racist.
4.2 divided by 3.4.
You said something about British people.
Oh, we said something about food.
That's really big.
British people are racist.
No, they don't.
Okay,
That's
no, they're,
racist, actually.
so they're not the same. So,
Not corresponding angles are not congruent.
corresponding sides are not proportional.
You're a racist. All pumpkin racist. That's a yellow pumpkin. You're a racist.
What does he say?
There's nothing to say.
Were you guys good on your trip?